All right, welcome folks to another session of Tiny Talks. Tiny Talks is a place wherein Rocket Alum share their learnings from real world work. And today we have Khushal here with us again, and he's going to continue his How to Scale series. Last time he talked about load balancers, how to handle traffic using that. Today he's going to dive into message queues. He's going to talk about how do you remove non-critical operations to reduce the API response time for a better user experience. I'm told it's going to be beginner friendly. So yeah, if this is your first time or you might have used it already, just um, keep asking questions in the chat whenever you have it. Don't wait for the end because the earlier you ask your questions, the faster the feedback goes to the speaker so that um, they can give more examples or give more context in a more relevant way. So yeah, that's about it. Over to you, Kushal.
Yeah, hi everyone. I hope you can hear me. Let me share my screen first. So, can you all see my screen? Is that? Can you confirm that you can see my screen? Okay,
Yes, we
yeah,
can.
okay. So, yeah, I'll be looking at this screen. So, just a bit of unline from the camera. We'll start. So, hi everyone, I'm Khushal. I work in the Strand Life Science. You can talk to me about travel, high grading, or anything else. You can find me on social media using this handle. So, we'll cover today's topic. Today's topic is optimizing API responses, optimizing API response timing with the message queues. So, let us look at the problem first. So let's assume a hypothetical scenario where you are owner of e-commerce website and your customers are complaining that the payment page is taking too much time for confirmation. So users are coming on your website and they're saying that we are doing the payment, but the confirmation of the payment page is very late. So it is a very critical task for your product. So you investigate further and see that what is wrong with this thing. So you look at the code and you see that backend API handling order confirmation is very slow, and you try to optimize it and see that what is further you can do. So you see that order confirmation email is taking too much time. So assume that you have a backend API where the user is coming and ordering something. So whenever the order is or payment is processed, you are sending the user that your order has been placed, and then later you are sending the user payment page that your order has been placed and this is all right. So the main blocking thing here is order confirmation email, which is taking too much time to send, and we are awaiting that thing. So the whole response time is increasing, right? Similarly, if you look at the problems like image upload or CSV download, all of these things are basically a time-taking process. So as the JavaScript is a single thread language, what happens is whenever a time-taking process or an thread blocking process happens, any request, any other request coming to our server, we'll have to wait for it. So hence it increases the response time of our APIs, right? So let us look at the one of the solutions. So this is the solution. We'll use the message. Many of you have used Spotify, and you have seen on the right side that a now playing song, right? The next thing is when we add a new song to the queue, right? So it says play next or add to queue. We can do that. So if you add queue, this is how it works, right? Similarly, the message queue works in the real time as well. So let us it better. So let's assume this box is a queue and we name it as a task queue, right? A queue basically works on a principle of FIFO. So whatever comes inside first will get processed first. So a queue has two main components in our case. So one is a producer and one is a worker. or you can call this a consumer as well, right? So if you look at the, you can assume producer as you yourself. So you are adding the songs in a queue, right? So you are producing a new job for a queue. So you're a producer, and the Spotify backend which is handling the next song. So whenever the song comes, it plays, and after that, next songs come to automatically plays, right? So this is what a worker consumer is doing. Now assume this T1, T2, T3 are songs, and this is how we'll process. We says, okay, then come to the queue, and then it will get played and processed, and then it will go out of the queue, right? The next song will come, it will come to the queue and played and processed, right? So in the meantime, all of the items will get in the queue, and as soon as the first one get finished, the next one will come and so on, right? So this is how the basic queue principle works in. Right? So if you look at here, I try to explain, we can add less priority tasks to the queue. So let's prioritize as in the in our previous example, right? We talked about the order confirmation email. So if you are ordering something on Amazon, right, you would more likely to see the web server or a mobile app where you see that order has been confirmed instead of your email checking. So if the email is 1 or 2 minutes late, it is feasible, right? If it's come 2 minutes late, it's fine. But the order confirmation page you should see is first. So that's why the email confirmation in our case is less priority task. So we can put it to queue and process this differently. So the target our thing is to keep the main thread of JavaScript as free as possible so that we can handle the complex logic task on that thing. Process item to queue one by one when the thread is free. So whenever the thread is free, we can just process the queued items one by one and it will go and process the task, right? As discussed, the queue works as a FIFO principle. Whatever item went first in the queue, it will execute it first. So why queue? Because we can run whenever there are less load on the server and we can rerun the failed job. So the problem with this is, let's just say email got failed, right? We cannot rerun the thing. We have to add another logic to rerun the job. So we can do error handling with this thing, can do job scheduling with this thing. So that's why we use the message queue, right? So let's see. Another thing is dead letter queue. This is part of error handling in the queue. So let us look at the scenario. Let us go to Teardrop again, and we'll say that all of these items are back again here, and let us add here them as well, right? So first assume that T1 a song came played, T2 came, T3 came, and T4 came. Let's just assume for now there are 4 items in the queue, and those 4 are processing, right? Now T1 get processed fine, T2 get processed fine, but at the T3 level we got error, right? So T3 has a problem, so we'll mark it as a red, and T4 got processed fine, right? So now this 4 item has been processed, but T3 has an error. If we were not able to complete the task to send whatever the data, let's just say email. So we were not able to send the email, right? So what we'll do is we have the data right now. We'll try to retry this thing. So we'll add the item again in the queue, right? Some new email thing come, new someone else ordered. So T5 and T6 also came, right? So this got processed. Now T3 again failed. Let's just assume the T3 again failed. Now T5 came, T6 came, this all processed. But T3 we will put this thing again, right? This is what retrying mechanism works, right? So the problem here, can you see the problem here? This T3 is getting into infinite loop again and again. Because it is failing, we are getting an infinite loop. So how do we tackle the situation? So this is where the error queue comes in. Error queue, also called as dead letter queue. What it does is we can move the infinite loop making job or item in the error queue. So let's say we have a number of retries on a particular queue. Let's just say this is the first queue, which is task queue. We have 6 items here, and we say that each item can be, if it failed, will be retried twice, and after that it will put it to error queue. So when the T3 came, T3 first came, it was error, right? Second time it got, we retried. So retry number one. Retry number one. we said that it has not been completed, so we'll put it again for retry. It got retry number second. Now it has not been processed and still the error we are getting, so we'll put it to the error queue, right? As you put in the error queue, what will happen? We can use this error queue as an alert system, monitoring system, logging system, or we can just tell developers that the particular email data is not getting or email is not going. Can you look at the data and see if there's a problem or not? So this is what I've written here. Let's just say let's say you are sending email on order confirmation, right? Due to some changes in data format, the email for a particular order is getting fed in a process in a primary queue. Primary queue is in our case is task queue. We can set maximum retries on a primary queue, but even then it is failing. So let's say we retry 2 times, but even then it is failing. Then the email data can be problem or some other problem can be there, right? So what we do is we'll add it to another queue. We'll just name can be anything, but we'll name in the case is error queue or dead letter queue, right? Same process. It is nothing new. There'll be producer and consumer as well. And we'll set up some alerting so we can notify the developers or admins about that there's a problem with this particular job and you need to work on it. So the admins and developers can know something has failed. This is called as dead letter, right? Next come the BullMQ. BullMQ is the library will implement the queue or message queue using the Node.js. It is built on top of Redis. So Redis is an in-memory database system. So if you have heard of other database, Mongo, Postgres, these are the hardware side. So basically, if you look at the Mongo or Postgres, this rely on the hard disk or the SSD of the system or the server they are in, right? The Redis in our case is in memory, so it is based out of RAM. So it is faster accessible, very fast accessible, as well as it has some uh, leveraging the data state of efficient job management. So basically, we can use the BullMQ to access the APIs of Redis and and we can process the data faster, right? And we'll use this thing as same as database. We can be used as same as database as well, right? So BullMQ, why are we using BullMQ? It has job scheduling features, error management features out of the box. So we don't need to uh, code it ourselves out. It gives us a function or methods which we can use for uh, automatic retries. There's a retry strategies available and the dead letter queues and job persistence. So whenever a job fails or server shutdown or something like that happens, so the last item which was not processed in the queue, which will process from that item only. So this is called as job persistence. We can do concurrency control as well. So basically, we can say for a particular job, let's just say we have 1,000 email to send, and we can say one worker is taking too much time to send. So we can say we can concurrency or simultaneously run the 10 workers, which will handle the jobs very well. So let off these things and we'll work out the thing. So I have initialized a very sample node project. It has mainly 3 files. First is the package.json. Second is producer.js, which is empty right now, and worker.js, which is also empty. So in the package.json, I have installed a dependency called BullMQ, right? And git ignore. So we'll start with the producer.js. We'll go to BullMQ documentation. Run jobs or job. Can you explain details? Yeah. We'll come to that, Raghavendra. So let us look at the BullMQ documentation. So if you look at the first thing, we have installation guide. So you can use npm or yarn and just install BullMQ. I have already done this step and you can see in my dependency file, there's a BullMQ already installed, right? Next thing is they've given a two things. One is to create a queue, which is to produce a queue, a worker or consumer, which will consume the task we give, right? So we'll copy this file into producer.js, save this thing. There's another thing is worker.js. We'll copy the same thing, different thing, sorry, worker file in the worker.js, and we'll try to run this thing, right? Let us try to run this thing. I have opened a script terminal just so that we can run two files. So I'll type no space file name.js, right? So I want to run producer, so I'll just producer.js. Now, if we try to see, it says that we are getting error on this particular port. So let us try to see what is wrong with this thing. So in this step, we said that we need bool MQ is based upon the Redis, right? So we need Redis for installation of this thing, Redis install in our local or in the cloud, so that we can store the data, whatever we are making queue and accessing the data from the Redis. So we need to install the Redis. For that, what we'll do is we'll just go to Redis platform and see there are two options available. One is a community edition, one is a Redis cloud. Community edition is this basically an executable that you can install in a local machine, or there's an Redis cloud option which is similar to MongoDB Atlas, right? If you have used MongoDB Atlas, you get connection string at the end. Similarly, in the Redis class, you will get the connection string at the end, and you can use this as well. We'll go with the community edition, but this is we'll use the Docker image to run Redis. So if we go to Docker Hub, you can see the Redis as an official Docker image, and you can just install using Docker pull Redis. This is the command. You can use this command to install this. And once you have done that, you can just do sudo docker images, and you will see that if you have any installed images for Redis or not, right? So we'll see. This is the Redis. I have installed this thing 2 months ago, right? So this has been downloaded in my local. Okay. So let me try that. Good. Now let us look at how can we start this Docker image. So first we'll see uh, if there's any process running or not. So for that we use the command docker ps. Docker ps is process status. So we have run this command. So this ITD flag is interactive terminal and detach. So Redis image so that we can maybe access this thing using shell or bash in the future. And there's a -p command which is port mapping basically. So there's a when we run the docker run command, and Redis will spin up in a container. So we want that particular Redis server's port 6379, which is a default Redis port, to our local machine's port, so that we can access the Redis using the similar port, right? So as soon as I press enter, what will happen is it will give me a container ID, and it will get detached because of this T command, right? So now if we go back to the this particular terminal and Control C and then try to rerun this thing, we don't get any error, right? If you see, we don't get any errors. So this is how it is done. I'll just do Control C again. Now let us try to understand the code. User.js. Here we just importing a queue, and we are making a initialization of basically a queue method, and we are naming a queue as a foo. So this name is very important, whatever you use here, which will be used in the worker. So let's just say we use this send email, right? We'll have to use this thing in the worker as well. So I'll just copy it. Now we have saved this queue with this particular thing, right? We can modify this thing as an subject, or we can just write order confirm, right? Order confirmed, something like this, right? And then we can just write body has been placed, something like this, right? And similarly, we just copy this thing to uh, below as well. I'll just write so that we can Right? So this is the basic thing. We have tried to add two jobs, which is first one is this order number one and second is order number two. And we have just run this function at the end. So what will happen? This function will run. You will add these two jobs to the queue. So this is the producer part. Now let's go to worker or consumer part. Here we are importing a worker and a Redis input library. So it is just to connect the Redis to our system. So this is not much a thing. If you use a Redis cloud, we'll have to basically add a connection string here, right? Nextly, we are initializing worker with a queue name. So what we'll do is we'll copy the send email queue here and we'll just paste it here, right? So that is right. Now, let us look at this thing. Wherever a job will come, it will try to console out the job data and then it will run, right? So let us start the server. So first I'll run the worker.js, node space worker.js. And you see there's no output coming from this worker.js because there's no item right now in the queue. But as soon as we to queues, right? So I run our space producer.js, right? So as soon as I ran out space producer.js and entered, the two items got processed because this was initially and there was no delay. I just added the console.log. There was no processing time needed. So that's why it got immediately, right? Let us try to add an let's try to add a bit of uh, set interval here, right? So what I'll do is I'll make a new function, right? This function anything. I'll just return a new promise with resolve, comma, reject, and a set interval, which will it will just resolve this thing. And then I'll make it 5 second delay, I guess. Yeah. So 5 second is 5000 milliseconds. So I will do a 5000 millisecond delay here. And what I'll do is uh, I'll just import call this function here, right? So what I'll do is I'll await this function here, and yeah, this is how it will done. Now let me add few more things so that we know that which job is running. So I'll add in job ID here. So we can do job dot ID so that we can get the job ID. If we go to the documentation back again, we can see that we have event listener on the workers, right? So we can see which job has been completed, which job has been failed. So let me copy this thing and add it to the end. And this is on worker, so this variable selection happening. I think we are curious type FIFO and bullet. Every time we are creating a queue is a type of FIFO. Yeah, yeah. So queue works in a FIFO fashion. You can change the thing by adding a delay, or we can add a different type of queues. But right now, what we are targeting. So whatever item first added. So if you look at the item one was added before first, right? Here. So item one was added first. So that's why this has been executed first. And secondly, it was added secondly. So it was added. I'll give you one more example just now. So this has been done. Let me try to rerun this producer.js thing. Okay, I have to rerun the worker.js as well. Now I'll rerun the producer.js. So if you see, this is the fifth number of job. So I have added a console.log job ID, right? So this is adding a fifth number of job, and it took 5 seconds to complete. So now this was printed. I should have printed after that, but yeah. And after this event has triggered, completed event, it says that 5 has completed. And simply, same thing happened for 6 as well. Now let me fail a job on purpose so that we can see if job is working fine now, right? So what we'll do is I'll just sorry, I'll just try to trigger an error. So I'll just check the job to data, right? I'll just check the job to data and dot what we have here. We have two things, subject and body, right? So I'll just change this string to one and two so that I just want to fail one, not both of them. So I'll just copy this thing. I'll just do job dot data subject. So whenever we do job dot data, we get whole object here. This whole object we got send it on the queue. We got whole object here. So I am doing job dot data, so we'll get whole object and then dot subject so that I get this particular string, right? So I'm matching this thing to um, here so that I can get only that item. And based on that item, I just want to return to new errors, anything, right? Yeah. So let me rerun this thing and hopefully we should get the, yeah, first one in the failed part. I'll also add a string here so that you can see better. Right, I'll just rerun the server and now I'll rerun the producer. So now look at this part, processing job number 7. Job number 7 will be the first 5-second interval will be there, and then it says that job 7 has been failed. If you look at this thing, 7 has been failed with order not processed, right? Because I added this thing, so I'm just checking if there is a particular string is in job and making it fail, right? So this thing will not happen. It will just get returned from here, and this will be catched by this particular event handler. ID is clicked. ID is an right now is a sequential number. So here I have let us say here, right? This is the first one. This is the second one, third, fourth, fifth, sixth. Let me just give you another example, right? I'll just do task queue, right? I just rename this basically queue. So the ID will start from the beginning. Hmm. Let's clear the terminal. File, right? And now I'll run the producer again. Now ID should be one number, right? So this is a sequential number. Yeah, it is a type of auto increment. So one, two, it will go again, right? So first one came, and I paid this thing. So this thing was catched by this particular event handler, and we got this console. Secondly, this got processed successfully, so we got this log here, dot data, and then this completed log, right? Now, so now let us try to do few more things we can do with the Willem queue, right? So as we told, when we also use priority to access priority of task, we can do that. I have to check. I haven't do that, but yeah, that is something I have added for thing you should explore right in there. But yeah, we can make priority queues and attach the priorities to that, right? Uh, I was talking about delay. So you wait and deploy me, or may all be lost. Not necessarily, Sandeep. I'm not sure right now. I haven't checked this thing, but I don't think it should be deleted. It should be in the Redis DB, unless I restart my server and not save the Redis database. If I again create a new build and deploy my, if I create a new build and deploy my B, all my uh, old queues will be lost. Sandeep, I don't think this will happen because Redis has not been restarted, right? So if I go to, there's a tool called Redis inside. So if I go here and check the queue name, I think it should be there. So we have the send email still here, right? And task we both are here. So the send email should work. Yeah. Unless we restart the server and the data will be lost. But even in that case, if you want to, you can save the in-memory data to a hard drive or solid drive using Redis, right? I won't go much on the detail on the Redis inside. That is not much useful right now. So I'll skip this part. But yeah. So I was talking about adding delay, right? So let us add delay. Again, this delay is in milliseconds. So we say we want to add 2 millisecond delay, 2 second delay. So now, even though this job is first, this won't processed first because this has 2 second delay, and the second job will process first because it doesn't have any delay. But then ordering will be still same because it is a FIFO, right? So ordering will be next. There's a third order, right? So third will be this, and fourth will be this. So let us look at this thing. I have not changed anything here, right? So yeah, I'll just restart the process producer only. Processing job number 4 first because it has delay, so it won't go first. It will the second will be go fourth number will go first, which has order confirmation 2, and then processing job number 3 will happen. Right. Next thing is we have some retries and exponential back office strategies. So we'll go to documentation again, and we'll see retry failing job. So look at the documentation; it is very easy and understandable. So try go for this particular thing section. You can see that worker handles the retry failing job by automatically. So if we look at the code here, they have given basically two things here. First is attempts. So how many retries we want? So we wrote retries number 2, right? So 2 times it will retry after once it failed. So if we say attempts 3, so it will try 3 times. Next is a back off key. Back off key has two things. First is a type and second is a delay. So let us uh, copy this thing and let me draw it here. Okay, I'll just do it here. So this is the back off thing. Back off thing is basically what when we retry the first time and second time, how much want to delay to add because it can be possible that server has basically crashed and we want to check if restarting the server or something, or if we want to check if there's an error. So we can add some delay to retries, right? So we don't want to retry to just again. So we'll add some delay, but there's a type of delays, the type of delays we can do. We can basically using exponential. So what will happen is the first time retries happen, right? So first retry, it will take 1 second. Second retry will basically take 2 seconds. Third retry will take 4 seconds. Because it is exponential, so first retry will happen after 1 second. Second is retry will happen after 2 seconds, and third will basically it will exponentially increase the amount of delay you add. So this is what the this particular type of exponential backoff is called, right? So you can try that as well. So we'll just add this thing into the our code. So let's just say we want to add this thing only. So we can just after the delay we can add it here, and well we'll make the attempts only 2. And yeah, let us run this thing again. So if you look at processing job number six will be this particular thing, order confirmation 2 thing, and job number 5 will be this particular job number 5. So it has failed once, process order not process, then it will add some delay, and then it will try. It will again add some delay and then try. So it will increase the delay exponentially. This is the logic with this type exponential, right? It has tried twice. Okay, 2 times only. So yeah, it has stopped. So it tried twice and it has stopped now. Now this done, it has a dead letter option. No, okay, it doesn't have any code. So basically what we can do here in this particular place, we can add a dead letter queue here, right? So now we saw that this uh, this thing we tried twice and nothing happening. So what we can do is whenever it fails, we can just check the retry card and based on that add dead letter queue to here. So so we'll have to basically initialize a new queue. So you can just you things got here. Just give me a second. Will add a new queue and just do yeah, real queue dot there's any job data, jobs. We just show in the micro. Right. I'll just go to schedule, check, save. Uh, this code has the DRQ. Yeah. So if you look at this thing, similarly, right? So I'm just what I'm doing is I'm getting on failed event listener. I'm moving this job to move to failed, and this is the RMS I'm passing, and this is the new queue name. So this is the new queue I have initialized somewhere around. I have not initialized this thing. I think I have linked the code, but yeah, basically I have to initialize this particular queue and then move this to uh failed queue basically. So this will go to dead letter queue. Next, we'll look at the scheduling of the thing. At the time of creating IO Redis connection, what all parameters need to pass if you are using for production ready application. So you just need to pass a connection string. Before this code thing is new. This IO Redis thing is new. Before we used to pass in the connection string here, we used to pass the Redis port and the URL basically connection URL, right? So before it was 127.0.0.1 colon 6376 something like that. That we search for this thing, right? Wherever this port we started, right? 6379. So that we have to pass here. Now it takes if it is in the local host, so on the same server, it will take it from there. Otherwise, if you have Redis on some other server or other port, you have to basically manually configure this thing. Okay. So you can read more of the connection here, connection part here. So yeah, if you can see connection host string and this particular port thing, you can separate out the workers and the producer as well. So you can put it on different uh, queues as well. Sorry, different Redis instances as well. But they should have a similar common database. So yeah, these are the things you can see on that particular thing. Next, we'll move to scheduling the job, right? So let's say if you ever seen schedule a job in LinkedIn or Twitter or Facebook. So let's just say if you want to post a birthday of someone or a New Year thing on 12th of 12th, sorry, December 31st, 12 p.m. or 12 a.m., whatever you say. So what you do is you don't want to wake up at that time and schedule the thing. So what you will do is you will go to Facebook post and you will just schedule the stream according to time, right? In the backend, what happens is the item particular your post goes to a queue, and whatever the data you post and image goes to the queue. And whenever the time ticks, this will go to it will hit a Facebook API for posting internally, and the post will get into the your timeline. So similarly, what we can try to do is what we can do here. So we can set the target date here. I have set the target date of 30th October 2025. So basically next year, right? And what I'm doing is I'm checking the current time as well. So I'm trying to find a difference, how much difference we need to do. And I'm getting that calculating in the millisecond using this get time function. So I'll get the delay in millisecond, and I'll just pass this particular queue I'm adding and delay. So delay will be in here, it will be in the big number. So this will work. This will work after a year and get posted to, if this is an API request, so it will get posted to a Facebook or whatever. So this is how scheduler works. Uh, I guess we have covered basic things. Let me just go back. We have covered automatic retries. This has been done. Data queues we have covered. Job persistent, yeah. This we can show you. So basically, job persistent here means that if a job is breaking something, let's just say if you're running whole MQ and you have 10 jobs and your node server shut down, which is handling the queue, it got shut down or the power got off the server, right? So what will happen is the data will get lost, but queue tried to job persistent. So whenever the last job which was not processed, it will get processed again from that particular job ID only. So this is what you get with the job persistent thing. Concurrency control. Concurrency control is, let's just say you have thousands of email to send, but you just have one worker which is taking too much time. So you can add a simultaneously multiple workers in the in the in the worker file, and you can process the multiple tasks simultaneously. So these are the things. I think we already had 12:46. If you don't have any questions, we can move to end of the presentation. So yeah, uh, now overall questions we can go ahead. For cron job to be successfully executed, server needs to be available all the time. Uh, Paras, you are saying for cron job to be successfully executed, the server needs to be available all the time, right? Not necessarily. Whenever let's just say server went off, right? If the server went off, what will happen is it will whenever due to job persistent, the last process ID will be there, right? So it need go into the queue and it will basically line up from wherever the last execution happened. But the job need to be run, server need to be run whenever the time comes, right? So that's when happen. Can you share the slide? Yeah, Anis, I'll share the slide in the comments. Yeah. If you want to give feedback, please. Yes. Any questions? I'll go from the start. There was one more cron job question in the start, right? I'll check that. So, Sanjeev has asked, please explain some scenario where we are uses something called as ODK, Open Data Kit, to get the data from some clients in the foreign country. And we have to fetch the data from there to our MongoDB servers. So in process of doing that thing, before we are having problem with data loss because of the synchronization time and sometime production or staging server went down, right? So we don't know item was. due to that thing, when we move to queue, we have a job persistence thing, and we can basically just not block the whole thread API thread, and now we can just move the or process the workers in the midnight only, and then keep the thread explain detail. To my knowledge, they are cron jobs. These are the basically task which run based on the time we set. It is generally used to do for any frequent coming program, basically, right? So let's just say you want to wish a birthday to your friend each year. You can just run a cron job for that, and if your computer is started at particular time, computer is running particular time, it will basically trigger a cron job, and your birthday request to a friend will go. Okay, they will explain this as well. I'll go to last final queue like yes. Uh, is producer consumer model is synchronous to PubSub model, or PubSub is totally different thing? I think PubSub is totally different thing. I'm still exploring that part, but yeah, this PubSub is not supported by WoolMQ. I had to move to RabbitMQ due to our company's one of the basically we had a requirement of PubSub, so we had to move to RabbitMQ due to this particular thing. So PubSub is not supported here. This is for basic message queues. So PubSub exchanges, those things are still not supported by PullMQ. Can we schedule any task in a between on queue like we are shuffling priority for tasks? So this is a message queue, Sandeep. We won't be able to do that here, but there are able to do dot in there because let's just say our OS is running right and it needs some syscall on priority. So this is what is handled by priority queues. So that is what I want to say that beyond the basic message queues, explore priority queues, and there's a normal queue, simple normal queue. You can make this yourself, and there are many more other queues, circular queue, event queue, etc. Right? So find out when they are useful. Right? Just like JS asynchronous option is this event queue, asynchronous way at the time next task will wait or what will happen. So queues are designed for that thing, right? One task at a time. So unless you are adding lot of workers, if there's a one worker which will handle only one process at a time or one job at a time, if there are multiple workers, it can they can handle the simultaneously. You can even do a particular thing like you can send a particular worker, you can do a success job on or a particular worker, or if you want to just retry, you can just send a particular worker that this particular worker will retry retries the job, not the main thing. Similarly, you can do. But if there's a single worker or consumer, those things will come one by one only. Anything else, guys? Okay, so I'll stop sharing the screen. Find me on social media and just ask. Okay.
Maybe you can just drop your hand in the chat.
Yeah, I'll just drop. Also, I'll drop the feedback form. So the I'm not available on Twitter nowadays, so I'm not including that part. But yeah, on LinkedIn, on GitHub or Blue Sky, you can reach out to me on Blogger Minutes.
Folks, in the comments question, like basically there are three questions. In the last question, feel free to suggest more topics as well if you want to. If you have some topics in mind that you would like some discussions or some sessions on, so yeah, feel free to add those um, topic suggestions as well in the form, and we'll wait for maybe 1 minute so that you fill out the form, because usually nobody fills the form after you leave. So fill the form, and then you can drop off. I think that would work the best. That would be like a win-win for everyone. And
Also, also I have added a reference slide which has an YouTube video which was done by Rocket Alumni only. It is more on the scheduler part of the queues. So yeah, please check that out as well. Yeah. Yeah, okay, Paras, I think it's from last time. So yeah, I floated the form last time, so it is same form. So you might have get it. Okay, no problem, Paras. Yeah.
cool. So I think I'll stop the
Uh,
recording now, because I think
yeah.
thank you, Kushal, for this session. I think bit by bit we're exploring a lot of scaling options. So yeah, it's pretty cool to see.
Yeah, a lot of people are interested in priority queue as well. So yeah, it's a good topic to explore for me. Folks, if you have any other things I can explore or you want to learn, please comment the topics. So yeah.
All right, I'll stop the recording now.